Hi, I'm Thomas Cocker with Page Commissioning and Tab, here on behalf on the Texas chapter of the BCA. We're going to be doing a series of videos on commissioning related to how-tos, in-field troubleshooting, and discuss interesting issues of the month. And today, we're going to be talking about a recent issue that we were able to solve. Basically, a client had contacted me because he had been having issues with his vestibule. Basically, he told me that the ceiling tiles at certain times of the day would just fly up out of the ceiling grid. And that was pretty much the only information I was given. Then he sent me the drawings, and which included the sequence of operation. And I was able to obtain the control submittal. So I went out on site to investigate the issue. I brought a manometer with me so I could take building pressures, because I had a pretty good idea what the issue was going to be. But so when I arrived on site, I went through the first set of double doors into the vestibule, and this is a drawing of the exact vestibule I was troubleshooting. You can see that the supply grills, it's only got two at 220 CFM each, and then you've got a return grill here, so it goes above ceiling, and then you've got a transfer duct to transfer it through. Now, if we do some quick math on this transfer duct and estimate how much CFM is actually going to be going through there. So it'll be 440 CFM going through a 12 by 12. So you carry the one and you'll get about 440 feet per minute through this transfer grill. And so that's reasonable, right? Nothing that would cause any issues with that. So basically you have a well-designed vestibule area. As long as this can keep up with the heat load, it shouldn't have any pressure issues. So why are we having ceiling tiles lift out of the ceiling grid? Well, it's got to be something else outside of this vestibule, or this box was not balanced correctly. So after arriving inside the vestibule, I could hear that there was an excessive noise on these supply diffusers. So then obviously, well, more than likely, airflow is not overflowing in here, right? So the next thing that I did to troubleshoot the issue is I opened this set of doors here, right? And then I had some people that were meeting me on site. And so I asked one of the guys to open this door here. And as soon as he did that, I felt a big rush of air come in, right? So then that tells you if the air is going inside the building, then that means the building is negative, right? So you have more exhaust than you do on your outside air. And this space below pretty much opens to the entire building. You have pretty large stairwells that go to the rest of the floors. So being able to measure it here gives you an idea of what the rest of the building is doing. So after this, I asked him to keep this door open here, and then I took a pressure on, I closed these doors and took a pressure across this door so I could see exactly how negative the building was. And my manometer read a negative 0.18, which is, I mean, that's pretty darn negative. I've seen buildings worse, but that's pretty bad. Typically, you want your building around, I can write this out. So you want building pressure to be between 0.02 to 0.05 positive IW inches water column. And so if you're able to maintain that, it'll be good because you don't have any infiltration coming in. You won't get, nasty mold in your walls and all that. So that's the pressures that you're shooting for. And we actually had a 0.18. So why did we have a negative 0.18? So I started looking into it a little bit further, and essentially this is kind of a, my drawing of a 3D rendering of that vestibule. And these are the ceiling tiles that were popping out at random times. But essentially, if you think that the building is negative, if you open these doors right here, all of a sudden you open up a path for air to flow in, right? And it can't come through that door. So it starts trying to come through this return, right? And I know we showed a transfer duct in this area, but in actuality, the walls did not go to deck there. They were open, and so that allowed a lot of airflow to flow through that area. So it actually, so much air was trying to flow through at certain times of the day that it would pull the ceiling tiles up so that it could get back to, the air handler essentially, or the exhaust fan. So what happened? Why was this happening? So I went to the sequence of operation. How did they program this building? So basically what I found was in the exhaust fan control, everything looked pretty normal, except for this little note right here. During economizer, exhaust fan shall modulate to full speed. Okay, so that means during the economizer that the AHU would go into, the exhaust fan is just going to go to full speed. Well, that could be an issue, right? And you go to the AHU control and it says during economizer, when the outdoor air enthalpy is cooler than the economizer set point, the economizer will act as the initial stage of cooling. So basically you're going to modulate your outdoor air, right, to maintain your discharge temperature in sequence with your cooling coil. So if your outdoor air is 100% open, it still can't cool down the space enough, then you're going to modulate your cooling coil. So this seems to be an issue because your exhaust fan going to full speed assumes that your air handler is going to have its max amount of outside air, but this sequence states that it, not necessarily will. It could be, it could be really, really cold outside. So you're mixing, potentially 32-degree air in with your return air, which is going to be coming in at 70 degrees. And, and if you have enough outside air mixed with the 70-degree air, you may be below your typical 55-degree set point. And so at that point, you're just providing minimum outside air, not maximum. Yet your exhaust fan doesn't know that. It's going to modulate to full speed. And so this sequence right here doesn't really work. So what they really need to do is they could do one of two things. The cheapest thing to do is do a fan track with the outside air flow station. So whatever the outside air flow station reads, your exhaust fan is going to track it. Now, to be able to do that, if you don't have a flow station in your exhaust, then you're going to have to set up a fan curve, right? So you're going to match fan speed to its associated CFM. Now, you can do this through its factory supplied fan curve, or you could build one in the field. Now, it's going to be way more accurate to build it in the field. If you do 3 to 4 traverses at different speeds of the exhaust fan's range, then that'll tell you how to plot the curve, right? And then all controls has to do at that point is say, if I'm at this speed, I'm going to be at this CFM, and I need to make sure that that CFM is about 10% less than my outdoor air CFM as a rough starting point, right? Because all buildings are going to be different. And once they program that, that should solve this issue, because then no matter what the air handler is doing through economizer, whether or not it's doing full cooling economizer with its, its full outside air is matching its supply air. So we're talking like if the supply is designed for 10,000 CFM and you're actually flowing 10,000 CFM of outside air, then your exhaust will know, and it'll go to about 90% of that value to make sure your building still stays positive, right? But not too positive. And it also makes sure that your building will never go negative, because your exhaust will always be below your outside air amount. The other thing that they could do is actually install flow stations inside the exhaust duct. And then, so that'll allow you to just simply know what CFM your exhaust is flowing at all times, and then you just simply set an offset. So whatever my outside air is flowing, I want to flow 10% less on the exhaust. So the exhaust fan would just modulate to maintain that. And that's pretty much, how I was able to solve the issue. I suggested the cheaper route just because it's cheaper, it's quicker, it's non-invasive, and that's what they did. If you like that video, please hit the like button. And if you want to see more videos, please hit the subscribe button. And remember, when it comes to building pressurization troubleshooting, never, under any circumstances,